Hi, my name is Bianca Lopez Parnetti, and this is my presentation on Lab 2 charge tapes. The purpose of this lab was to revisit the results from Lab 1 charge tapes, but by this time treating the tapes as lines of charges and not as single concentrated point charges. So as you can see in the little visual, it's the entire line of the charge. So the initial conditions were taken from Lab 1 when we performed the experiment. We have the tape mass of 2e-4 kilograms, the tape length of 0.2 meters, and the distance between tapes being 0.025 meters. So some relevant physical principles used in this lab relate to forces and equilibrium. So the gravitational and electric forces are expected to cancel out because you had the floating top tape at equilibrium, meaning that all the forces cancel out in the y direction. And then more specifically, the electric force and field. The E field was modeled as integrated point charges along the entire length of the tape. And then Coulomb's law was used to solve for the final upwards electric force to cancel out the gravity. So some relevant calculations. First, I started off by calculating the magnitude of gravity, which was found to be 1.96 e to the negative 3 newtons. And then I related that to be the same magnitude as the electric force. And then by plugging in this new formula to find the magnitude of the force and the entire as lines of charge and not as a single charge, I found that the final charge value was found to be 2.37 e to the negative 8 coulombs. So as a preview of the lab results, first for Lab 1, modeled as a point charge, each tape had a charge of 1.17 e to the negative 8 coulombs. And then in Lab 2, modeled as lines of distributed charge, each tape had a charge of 2.37 e to the negative 8 coulombs, which was a big jump in difference. And the system was the same, the top tape, which was modeled as red balls, and then the surroundings was the bottom tape, which was modeled as the blue balls. So then I had the creation of my computational model. First, I started off with my constants and my initial conditions, this being the gravity, the mass of the tape, the length, the distance between them, and then the estimate for the charge, which I calculated previously. Then I had the E-field calculations, or the setup to calculate the E-field, which I took from my Lab 1 code, and then the modeling of the tapes as lines of charges. So this was continued in this next part. And then finally, the calculations of all the forces by integrating everything together. And we solved for the net electric force and gravitational force, and that was it. So here are the results of the computational model. We have the magnitude of the electric force being 1.65 e to negative 3 newtons, and the magnitude of the gravitational force being 1.96 e to negative 3 newtons. So there is a bit of a difference, meaning that they didn't exactly calculate to cancel each other out. So that indicated there was some error. So some possible sources of error are obviously the idealizations of perfect conditions. We have ignored air resistance from the floating top tape when it was moving and repelling away, the assumption of equal distribution of charge alongside the entirety of the tapes, and also the possible loss of charge of tapes during the experiment when we were handling and touching everything. So some similarities and differences between Lab 1 and Lab 2. Some similarities were that the electric and the gravitational forces were always close in magnitude but didn't quite cancel each other out, so not everything was performed correctly. But some differences were that obviously the tapes were modeled as lines of charges instead of an individual concentrated point charge for Lab 2 compared to Lab 1, and the charge for each tape was significantly higher in Lab 2, being around double the charge found in Lab 1. So now onto the additional questions. What if you had modeled each of your tapes as a single point charge like in the previous lab, and then to compare the value of the charges? So as I mentioned before, in Lab 1 I got a value of 1.17 e to the negative 8, and then in Lab 2 I got a value of 2.37 e to the negative 8. So this magnitude of the charge on the tape in the second one was basically double the value found in the first lab. So there was a significant difference. And then secondly, why does these estimates vary? And which one is more likely to be closer to the real value? And I said these Values absolutely differed, but the lab 2 result was likely to be more accurate since it accounted for the actual shape of the tape as in line and not as an actual point, because that's just completely unrealistic. It's not just a single charge, it's an actual line of tape. And that's all that I have. Thank you so much for listening.